The second learning objective in PS2-0, all about kinematics, is a conceptual one. It's more about understanding what displacement, distance traveled, acceleration, velocity, speed all are. So let's read this together as usual and try to understand what it's saying. So what this is saying is I can explain, so first off, that is our vocabulary word, right, or verb right there. It is what you're expected to do. You're expected to be able to explain the differences. Nothing about calculation. This is not about calculation at all. It's all conceptual physics on this learning objective. So what are you going to explain? You're going to explain velocity in terms of displacement. So basically, define what velocity is in terms of displacement and what acceleration is in terms of velocity. So you're basically just giving definitions of these things and understanding what they mean and what they are. And lastly, you need to understand, bit of a verb there, understand, although I'll be determined by whether you can explain it or not, the difference between speed and velocity. So really the vocabulary words here are speed and velocity. So I can explain velocity in terms of displacement, acceleration in terms of velocity, and understand the difference between speed and velocity. So let's go over some of these terms. If you watched the other video of PS2-0.1, where we were talking about calculating these two, you've probably seen these definitions already. Well, let's go over them again. So displacement is how far away you are, or an object is, from some other point in space. And it's not just how far away it is, it's also in what direction, because this is direction dependent. Displacement depends on what direction you're going. If you're going to the left, to the right, up, down, north, south, east, west. Here is a demonstration of that. So let's say you have this person that started at this location right here and travels along this blue, it's being highlighted as red, but along this blue path, that's how their actual path. That's actually how they are traversing this world, going through space. Their displacement is in red here. It is the straight line from where they started to where they ended. And typically, though, this would be a vector, so it would be an arrow, and this arrow shows the direction as well. They started here and ended over here. So that's what displacement is. Straight line from where you started to where you ended as a vector, which is an arrow essentially. The magnitude of the arrow is the distance, and the direction is where it's pointed. Now let's contrast that with distance traveled. Distance traveled is just the length of the path taken. So remember, this blue path is actually their path through space. If you were to take this path and stretch it out against a ruler or against a meter stick or a measuring tape and measure just how long that path is after you've straightened it out, that would be the distance traveled. Now, this is something called a scalar, and a scalar is not dependent on direction. A scalar has no direction. You could think of some other scalar quantities. For example, another scalar quantity might be, so e.g. is an expression for an example, essentially. One of those is weight. You know how much something weighs, your weight. You step on the scale, what do you see? A number. But does that number have a direction? No, that doesn't make sense. Now, a change in your weight, so whether you increased your weight or decreased your weight, does have a direction. But just the weight itself doesn't have a direction. It doesn't make sense for it to have a direction. Time. Now, time can have a direction if you're talking about like a change in time. But if you're just talking about what the time is right now, that doesn't really make sense. It doesn't have a direction. And there are many other quantities that are, in fact, scalars. They don't have a value. And later, we're going to learn about energy. Energy is one of those as well. It is a scalar value. It is not a vector. So that is the difference between displacement and distance traveled. And why we had to go over that is because it's fundamental to the difference between velocity and speed. So let's go to that. Velocity. Let's talk about velocity. So velocity is the change in displacement per unit of time. It's the rate of change of displacement, how much the change is of displacement is changing per unit of time. And we've seen the equation for that, the change in displacement, so delta x over delta t. We've seen this expression. And another thing that's important about this is it is direction dependent and it is a vector. So displacement was a vector, and so is velocity. And that's because it uses a vector in the equation, essentially. It depends on a vector. Now, speed is what we typically think of in our everyday life. A good example is your car's speedometer measures speed, not velocity. Because velocity depends on your direction. Your car's speedometer doesn't care whether you're going forwards, backwards, left, right, up, down, whatever. It doesn't matter what direction you're traveling. Your car's speedometer is going to read how fast you're traveling. So it's direction independent, and it's a scalar. It does not have a direction. A good example of the difference between this velocity and speed is if you travel in a circle. So let's say you're going to travel in a circle and the total path length, so the distance traveled, is going to be 30 meters. And let's say you transverse that in 3 seconds. That would mean your speed, what you typically would think of, is 10 meters a second, because every second you traveled 10 meters, assuming you were going at constant velocity. We'll go to non-constant velocity when we talk about acceleration. But assuming you're going at a constant velocity, you're going about 10 meters every 1 second. But what's interesting is your velocity is 0 meters a second. Because you ended back where you started. And remember, velocity uses displacement. And displacement says how far away are you from where you started. And if you're not any farther away from where you started, your velocity is 0. Another way you could think of this is you spent some time going in the right direction, but you spent an equal amount of time going in the left direction. And so those two distances canceled each other out. Those two velocities canceled each other out. You had some positive velocity, and then you had an equal amount of time in the negative velocity. So overall, your velocity averaged to 0. Because that's what velocity is in this class. It's an average displacement per unit at a time. And finally, let's talk about acceleration. So acceleration is just the rate of change of velocity. You've seen the equation before. Average acceleration equals the change in velocity over the change in time. It's just how much does your velocity change per unit of time. Now, one thing that is important is, many things are important. And the first one is that this is direction dependent and it's a vector. Acceleration can have a direction. It's not like your weight or energy where it doesn't have a direction. Acceleration does have a direction. It can be negative and it can be positive. Another important point about acceleration is that it doesn't just rely on the velocity changing in magnitude. For example, let's say you have an object that is traveling to the right at 3 meters a second. And then later in time, it is traveling to the left at 3 meters a second. The number here, 3, representing how fast, the magnitude of the velocity, didn't change. But I think everyone would understand that there must have been some acceleration. That's an obvious case. But a less obvious case would be, let's take this one. Let's say you're going to the right at 3 meters a second. But then at a later point in time, that arrow just bends slightly up. And now you're going at just a slightly different angle at 3 meters a second. Was there an acceleration? In other words, another way to put this is turning accelerating? And it turns out, yes, turning is accelerating. Why? Because there's a change in the velocity. The velocity is not just the number, it's also the direction. And the direction has changed. So therefore, there is acceleration. Lastly, I'll leave you with a problem, a task for you to complete to test your understanding of the concept. So describe a scenario where an object is accelerating, but its speed remains constant. Also explain why that could happen using all the vocabulary that was presented.